All right, today we are diving into a really radical idea. What if that explosive, faster-than-light inflation at the very dawn of our universe wasn't some deep mystery, but was actually an inevitable consequence of space-time itself? Let's get into it. So, we all know our universe is expanding, but the theory of cosmic inflation says that for just a tiny fraction of a second right after the Big Bang, it expanded exponentially, literally faster than the speed of light. This is what smoothed everything out, creating the cosmos we see. But the big question has always been, what was the engine that powered this incredible event?
You know, this whole idea of cosmic inflation is huge. It solves massive puzzles, like why the universe is so incredibly uniform and flat. But in science, when you solve one mystery, you often create a brand new one. And this one's a doozy. What was the engine that actually powered it all?
Well, the standard answer is something called the inflaton field. And here's the problem, right? It's a complete black box. As you can see here, we've never detected it, we have no idea why it started or why it stopped with such perfect timing, and we don't know how it supposedly created all the matter in the universe. It's basically a placeholder, a patch for a deeper mechanism that we just haven't found yet.
So, what if we've been looking at this whole thing completely backwards? What if inflation wasn't driven by some mysterious field in space, but by the fundamental behavior of space itself? Now that is the core idea we're going to unpack today. To really get this, you've got to perform a little reset of your intuition. We have to be willing to set aside our everyday ideas about things like objects, explosions, and maybe even time itself.
All right, here's the mental reset we need to do. Step 1. Stop thinking of particles as these little fundamental things. Step 2. The Big Bang wasn't an explosion in space, it was a transition of space. And that leads us right to step 3. Imagine a pre-universe state of just pure, unified potential.
So picture this. Before anything we know, there was just a perfect, uniform oscillation of space-time. Think of it like a perfectly still, infinite lake, where every single point is in perfect sync, a single phase-coherent rhythm across the entire system. It's a state of pure potential, yeah, but also one of incredible tension, just waiting for a reason to break.
And that brings us to the main event, the moment that perfect, balanced state of tension finally, and catastrophically, gave way. You know, the source material makes a really crucial point here. Perfect symmetry? It's not stable. It's actually incredibly fragile. It's like balancing a pencil perfectly on its tip. The slightest jitter, any tiny imperfection, and the whole thing comes crashing down. This perfect pre-universe state was exactly the same. It was dynamically unsustainable. It had to break.
And this slide just lays out the difference beautifully. On one hand, the standard model gives us an explosion of stuff, all powered by something we've never even seen. On the other hand, this framework gives us the very fabric of reality undergoing a fundamental phase transition, a shattering of its own perfect order.
This is the absolute heart of the idea. The Big Bang wasn't a bomb going off in an empty room. It was the room itself, space-time, losing its perfect synchronization. That phase decoherence, that instant where everything fell out of sync, that is the Big Bang. And here it is. This is the punchline. This violent runaway process of space-time shedding its own symmetry, separating into different phases, that is inflation. There's no need to invent some extra inflaton field. Inflation is just the geometric relaxation of space-time itself. Okay, so if inflation is just space-time fracturing, that's a pretty neat solution for the start problem. But wait a minute, it creates a new challenge, right? If it's a runaway process, what on earth could possibly stop it? Yeah, this is the other half of the whole puzzle, isn't it? Remember, the standard model requires that inflaton field to not only magically turn on, but to then turn off with insane fine-tuned precision. So, how does this new framework solve this stop problem?
So during this fracture, space-time was just going wild. It was in a state of free runaway oscillation. Think of it like a spring that's been compressed for an eternity and is suddenly let go. It expands exponentially just to relieve all that built-up tension. That geometric relaxation is what drove the faster-than-light expansion.
But, as this was all happening, something truly amazing occurred. Imagine ripples on a pond, right? Crashing and interfering with each other. Well, some of that chaotic oscillation of space-time literally tied itself into stable, self-trapped knots, kind of like persistent whirlpools that form in a chaotic river. These topological knots, These stable patterns of space are, according to this framework, the very first particles of matter.
And this means the solution to that runaway expansion was baked right into the process from the very beginning. The birth of matter was inflation's own built-in off switch. The logic here is just so elegant. It's beautiful, really. First, the fracture kicks off the runaway expansion. Then, that very expansion allows matter to form as these knots in space-time. And here's the genius part. The energy that was driving the expansion gets locked into the mass of those knots. The engine literally runs out of fuel, and inflation just stops. Automatically. No fine-tuning required.
You know, a good story is one thing, but the real test of any theory is, can it explain what we actually see out there? So let's connect this idea of a phase fracture to the universe we all live in.
And what's just so compelling about this whole framework is that this single event, this one moment of lost symmetry, has the potential to elegantly solve some of the biggest questions we have in cosmology without adding new, undiscovered fields or mysterious forces.
So that cosmic uniformity, why is the universe so smooth on the largest scales? Well, it's a memory of that perfect coherent state it came from. And the origin of galaxies? Whoa! They're just the frozen, blown-up patterns from tiny, microscopic jitters that happened during the fracture. And dark energy? Get this. It could just be the leftover tension of space-time still trying, billions of years later, to iron out the geometric wrinkles, the scars, left behind by matter.
This quote from the source material just completely reframes everything. Let this sink in for a second. The Big Bang didn't happen at a moment in time. It was the very event that created the possibility of a sequence of moments. It created phase ordering. It created what we experience as time itself.
So, when we look up at the night sky, at the cosmic web, at all those galaxies strung out across billions of light years, what are we really looking at?
This framework proposes a stunning, mind-bending idea that the largest structures in our entire universe aren't just collections of matter. They are the magnificent, frozen interference patterns from that single moment when space-time itself shattered its own perfection. That is a truly profound thought to end on.